Today, I would like to discuss anodic oxidation. Aluminum is utilized in a variety of applications, but for the sake of this discussion, let's focus on fixtures that are manufactured using extruded aluminum profiles, which is an application that many of us are familiar with to some extent. Aluminum itself is a very lightweight material, resistant, and has enough corrosion resistance. If exposed to atmospheric agents, it tends to oxidize and present an unpleasant effect, deteriorating over time. And consequently, one of the operations to which aluminum is subjected is oxidation. That is to say, an anodic oxidation operation is carried out, that is, a chemical coating, let's call it that. In practice, aluminum is made resistant to atmospheric agents. Normally, there are electrochemical, electrogalvanic baths, which are passed through by an electric current, and a hard anodic oxidation layer is deposited on the outer surface of the aluminum through a galvanic chemical process, known as anodic oxidation, to enhance its resistance to atmospheric agents. There are many types of anodic oxidation. I don't want to go into detail because honestly, it's not my field. We typically handle the cooling aspect of these bathrooms, as it is evident that these bathrooms where anodic oxidation takes place experience heating as a result of being traversed by electric current. These bathrooms need to be cooled, but there is a problem. What is the problem? What is usually the solution inside these bathrooms is not water, it is a solution of sulfuric acid at a low percentage. We are talking about 20%, but it depends on the type of oxidation that we have to do, and that needs to be maintained at an average temperature of 20-25 degrees Celsius. Also, in this case, it depends on the type of oxidation. There can also be lower temperatures for harder oxidation modes. Cooling it down is simple, okay? Refrigeration units can be used. Tap water can be used with heat exchangers. Yes, but the heat exchangers must be made with special materials that obviously resist corrosion because of the presence of sulfuric acid. We clearly manufacture both conventional plate heat exchangers with materials that can be either titanium or highly alloyed stainless steel, or we utilize T-coil immersion heat exchangers, also fabricated in this instance with highly alloyed stainless steel. Besides the challenge of choosing the material for these heat exchangers, there is also the one related to the thermodynamic calculation. Can we discuss it in an upcoming video? If you're interested, for sure. Good evening.